Next question. A football kicker can give a ball in an initial speed of 25 meters per second. What are the least and the greatest elevation angles at which he can kick the ball to score a field goal from the point 50 meters in front of the goal spot, whose horizontal bar is 3.44 meters above the ground? So this question really don't much information. They only have the speed, initial velocity 25 meters per second, and this is 50 meters in front of the goal spot. And we also know this will be horizontal bar is 3.44 meters. In order to kick the ball and go there, we have to below the bar. We cannot go over, then it will flow away. We cannot go. So let's try this question. It's because horizontal velocity, the x component, velocity of x component always is constant. So we're going to try solve this question because we have the 50 meters, the distance from the kicker in the point to the goal. So I'm going to write here initial x minus x0 equals initial velocity multiplied by cosine theta to find out initial velocity horizontal or x component, and multiplied by time, that equals 50. So initial velocity we already know 25 meters per second times cosine, we don't know the angle, times t equals 50. From there we can represent our time. We can calculate by 50 over divided by 25 cosine theta, or we simplify, we can have 2 over cosine theta. Now we want to go for the vertical or y component. Y minus y0 equals the initial velocity multiplied by sine theta to represent the vertical or y component multiplied by t minus 1/2 gt squared. So our time, we want using this value as the time. The initial velocity is, we know, is 25 times sine theta times 2 over cosine theta minus 1/2 g is 9.8, t is 2 over cosine theta square. Then we calculate, this will be 50 tangent theta minus 4.9 times 4 over cosine theta square. So we'll go simplify further. I have this one, it will be 50 tangent theta minus 19.6 and 1 over cosine theta square. But we know the trigonometry identity. 1 over cosine theta square, we can get equivalent to 1 plus tangent theta square. So we won't using that. Go further, this will be 50 tangent theta minus 19.6, 1 plus tangent theta square. Therefore, I want to represent the function, quadratic function, negative 19.6 tangent the other square plus 50 tangent the other minus 19.6. That's vertical or y displacement, the y component displacement. That need to be when this hit the come to this position have to be less than 34, less than 3.44. So in order to solve this, I have negative 19.6 tangent the other square plus 50 tangent the other minus 19.6 minus 3.44 less than 0. So this will be negative 19.6 tangent the other square plus 50 tangent the other minus 23.04. Now I'm just consider tangent as our variable. So by using quadratic formula, tangent the other equals negative 50 plus minus square root of 50 square minus 4 times a is negative 19.6 times negative 23.04 over 2 times negative 19.6. So I solving this, I have tangent the other, I getting 0.604, or another value I have here is 1.95. So I'm going to arctangent our angle. I can calculate by arctangent 0.604. I getting degree 31 degree. Another angle I have here is tangent negative 1, 1.95. I have 63 degree. So this will be two answers. The initial question they was asking what is the least and the greatest elevation of the angles. So least is 31 degree and the greatest is 63 degree. That's the answer for this question, and we went over together how to solve this question. Okay, that's it. All right. See you next time.